8.2 Polygons. A polygon is a closed figure in a plane determined by 3 or more straight line segments. So you have lines, connect the dots, that's a polygon. It can look odd, it can look funky, doesn't matter. These are all polygons because it has 3 or more lines and it creates a shape and it's all enclosed. A straight line segment that form the polygon are called its sides, and a point where two sides meet is called the vertex. Plural is vertices. The union of the sides of a polygon and its interior is called the polygonal region. A regular polygon is whose sides are all the same length and whose interior angles all have the same measure. So a regular polygon, it's like an equilateral triangle, a square. All of those, they're regular because everything's equal. It's nice and neat. So regular polygons, this one would be regular, this one would be regular, because they're all equal. These are not regular polygons. They're polygons, but not regular. Polygons are named according to the number of sides. So triangle is 3 sides, quadrilateral is 4, pentagon is 5, hexagon is 6, heptagon is 7, octagon is 8, nonagon is 9, decagon is 10, dodecagon is 12, isosagon is 20. I mean, it goes forever. Those are just some of them. Those are the most common. Sum of measures of interior angles. The sum of the measure of the interior angles of an insided polygon is n minus 2 times 180 degrees. So if we know the number of sides, we can determine the inside all the angles. You know how a triangle, it all equals 180 all together inside? That's what we're talking about. If I give you a 7-sided shape, what is all the angles equal on the inside? So let's find the measure of interior angles of an octagon and find the measure of an exterior angle. Alright, let's find the measure of interior angles of an octagon. So that tells me I'm going to use the formula n minus 2 times 180 degrees. N is the number of sides. So an octagon has 8 sides. Right, octopus, 8 legs, or 8 tentacles, 8 sides. So we have 8 minus 2 times 180 degrees, so that's 6 times 180 degrees, and 6 times 180 degrees is a 1080. So an octagon, if you draw it out, all the angles on the inside will equal 1080 degrees. Now, let's find the measure of an exterior angle. So what that means is I'm going to attempt to draw an octagon. It's going to be horrible, bear with me. I cannot draw to save my life. So octagon is 8. I don't need to. I'll just, right here, boom, I have an octagon right there. Alright, so here's an octagon. How do we know? It's 8 sides. Well, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8-sided shape. Now, we want to find a measure of an exterior angle, meaning I want to find that angle right there. If I extend it out, what's that angle? So we know total everything on the inside is 1080 degrees. So if it's all 1080 degrees and it's a regular polygon, can't we determine at least one of them? Right? We can determine one of them on the inside, and we do that by dividing. So we're going to take our 1080 and divide it by how many sides we have, which is 8. And we get 135 degrees. That means this right here is 135 degrees. Each of them, each corner right here, each angle is 135 degrees. Now we want to know if we extend a line out, what's going to be this angle right here? That's actually, you see how it's a line? I said if you extend the line out, a line is 180 degrees. So they're supplementary angles. So we take our 180 minus 135, and we get 45 degrees. So if we extend it out, this is 45 degrees. And it makes sense because it's an acute angle. It's small. It's not a really, really big angle. So it does make sense that 45 is that angle. Alright, types of triangles. We have acute triangles. That means all angles are acute. Obtuse, that means one angle is obtuse. A right angle means one is 90 degrees. Isosceles is two equal sides, two equal angles. Equilateral, meaning everything is equal, and each angle is actually 60 degrees. And then scalene is when nothing's equal. It's just a odd looking triangle. It's funky looking. Two figures are similar if their corresponding angles have the same measure and the lengths of their corresponding sides are in proportion. So similar figures have the same angles but different sides, but they're proportional. So we're going to use similar figure triangles to find the height of a tree. Monique plans to remove a tree from her backyard. She needs to know the height of the tree. Monique is 6 feet tall and determines that when her shadow is 9 feet long, the shadow of the tree is 45 feet long. And there's the figure. How tall is the tree? Alright, so these are similar figures because you see how Monique creates a 90-degree angle with the ground? So does the tree. So similar figures are always going to be proportions. Proportions are when you have a fraction equals a fraction. So the first thing we want to know what the heck is the height of the tree? How tall is this tree? Because how is she going to measure that tree? What if she doesn't have a ladder, right? Maybe she wants to call a company and be like, hey, I have this tree, but I don't even know how big it is. You need to know how big it is. So we want to know the height of the tree. How tall is that tree? We want to know this distance right here. We want to know the height of that tree. So that's the first thing we're going to put when we have a fraction. Now a proportion is when we have a fraction equals a fraction. So the first thing we want to know is the height of the tree. That's the exact thing we're going to put first, because that's the first thing we want to do. The height of the tree. So the height of the tree, something we know about the tree. Something we know about the tree is we know the shadow of the tree. So do you notice on top I put my tree information. Now on the bottom, height goes with height, length goes with length. So on the bottom, if we already have height of the tree, something we know is the height of Monique. My friend Monique, this is who I put this example on. Her name is Momo. So Monique, Momo, same thing. Okay, so we know the height of Monique. So if the left side is height, the right side needs to be shadow. Now, do we know the shadow of Monique? We do. Her shadow is 9 feet long. So let's go ahead and plug in our numbers. We don't know the height of the tree. We know the height of Monique. She's 6 feet tall. She's not really. She's like 5 foot, which is funny. And it's going to equal the shadow of the tree. The shadow of the tree is 45 feet. And the shadow of Monique is 9 feet. And since it's a proportion, we just cross multiply. So x times 9 is 9x. 45 times 6 is 270. We're going to divide by 9 to get x by itself. So we get x equals 30. That means the tree is 30 feet tall. Congruent figures. If corresponding sides of two similar figures are the same, the figures are congruent. Corresponding angles of congruent figures have the same measure. So congruent means same. If you're in congruency with someone, meaning you're on the same path, the same thought, the same values of them, right? So we have triangles ABC, and ABC. So this is the next figure, ABC, and they're congruent, meaning they're the same. So we want to find the length of AC, the measure of CAB, and then measure of ACB. Alright, we want to find the length of A to C. So here to here. Now let's look to our other triangle and see if we have a length of AC. Oh, we do. It's 13. Congruent means they're the same. So this length is 13. Alright, let's find the measure of angle CA. Oop, did that wrong. CAB, meaning we want to find this angle right here, angle A. Let's look to the other triangle to see if we have angle A. We do. It's 60 degrees. Alright, let's find the measure of angle ACB. So ACB, that means angle C. Let's look to the other one and see if we have a C. Oh, we do. It's 50. So 50 degrees. Congruent means just look to the other triangle for the information. It's going to be the same information, or the other shape, the other figure. Alright, quadrilaterals are four-sided polygons. The sum of every quadrilateral is 360 degrees. So you have a trapezoid, two sides are parallel, a parallelogram, meaning both pairs of opposite sides are parallel, both pairs of opposite sides are equal in length, meaning opposite sides are the same, and they're parallel. A rhombus, it's a diamond, that's all. Both pairs of opposite sides are parallel, the four sides are equal. So the difference between a parallelogram and a rhombus is a parallelogram is a rectangle, a rhombus is a square. A rectangle, both pairs of opposite sides are parallel, both pairs of opposite sides are equal in length, the angles are right angles. A square, everything's the same. We know what a square is. Alright, we have trapezoid ABCD. See how we have four letters, four sides, quadrilateral. Let's determine the measure of the interior angle X and determine the measure of exterior angle Y. Alright, so we know a quadrilateral, all angles equal 360 degrees. So all the angles we have, the one we're trying to find, we have X plus 130, and we have two 90-degree angles, so plus 90, and it's going to equal 360 degrees. So let's add up all our numbers. So we have X plus 310 equals 360. Subtract 310 degrees to get X by itself. And we get X equals 50 degrees. That means this is 50 degrees. If we want to find the exterior angle, you see how we continued the line out? If we continue the line out, we know it's 180 degrees. So 180 minus 50, we get 130 degrees. And that makes sense because it's an obtuse angle. It's a big angle. So it makes sense that it's 130.